For this video, the learning objective will be, I understand how horizontal translations in graphs are represented in function notation. When a graph is moved to the left or right but maintains its shape, we say that it has been translated or shifted to the left or right respectively. Here we'll look at example 1. One way of doing this is to take points from the original graph and move each of them 1 unit to the left, in this case. Then draw in the shape of the new graph. Label the original graph f of x and the new graph, or the translated graph, g of x. You might recognize f of x as the parent function, f of x equals x squared. But what function represents g? It will now be useful to look at the tables associated with these two graphs. Notice how the inputs for the functions are related when the outputs are the same. This pattern will continue on like this forever. Notice that the functions g and f have the same output when the input for f is 1 unit larger than the input for g. Since the input for f is now x plus 1, we have f of x plus 1 is equal to the quantity x plus 1 squared. But that means that g of x is equal to the quantity x plus 1 squared. And we have landed on something really important. When we shift a function 1 unit to the left, we can add 1 unit to the input to get the new function. This is a demonstration of the general rule, and it's definitely the punchline of this video. When we have a function that we translate h units to the right, the new function will be f of x minus h. When we have a function f that we translate h units to the left, the new function will be f of x plus h. This way of thinking about it assumes that h is greater than 0, or that h is a positive number. Even more generally, we can say, given a function f, a new function g of x is equal to f of x minus h, where h is a constant, is a horizontal shift of the function f. If h is positive, the graph will shift right. If h is negative, the graph will shift left. I hope that you now better understand how horizontal translations in graphs are represented in function notation. Thank you so much. Take care.